Good day everyone! Welcome to Fluid Mechanics.
By the way, I'm Danilo Tatang
And I am Miss Maurice Morelo Delgado Barba of Bisel 2B from Central Bicol State University of Agriculture. So for today's video everyone, we are going to discuss to you what is Pascal's principles, and also we are going to show you a video that shows the applications of Pascal's principles entitled
Hydraulic Control Machines. So, by the way, what is a Pascal's principle?
Yes, that's the right question, partner. So, but first, before showing the videos, let me discuss to you what is Pascal's principle.
Pascal's principle, also called Pascal's law, and fluid, gas, or liquid mechanics, statement that in a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of container. The principle was first enunciated by the French scientist Blaise Pascal. According to Pascal's principle, in a hydraulic system, a pressure exerted on a piston produces an equal increase in pressure on another piston on the system. If the second piston has an area 10 times that of the first, the force on the second piston is 10 times greater, though the pressure is the same as that on the first piston. Pascal also discovered that the pressure at a point in a fluid at rest is the same in all directions. The pressure would be the same on all planes passing through a specific point. This fact is also known as Pascal's principle or Pascal's law.
Since you already know what is Pascal's principle, in addition with that, in 1950, Blaise Pascal invented a syringe as an application of fluid mechanics, which is now the Pascal's law, and we made a miniature of a hydraulic machine which used the syringe as an application of Pascal's law. But before we present it to you, let us first measure the dimension of a cylinder, which is the syringe, and calculate the force that it can generate. The miniature that we made used a syringe of 5 ml syringe and a 10 ml syringe. The 5 ml syringe has a length of 2.83 inches or 0.72 meter, and its width is 0.56 inches or 0.14 meter, while the 10 ml syringe has a length of 3.58 inches or 0.91 meter, and its width is 0.73 inch or 0.18 meter. So let us now calculate the force that a syringe can generate. Consider that we apply the force of 47 Newton in a plunger plunge of the first syringe 10 ml. What is the force of the second syringe 5 ml can generate? In solving this problem, we'll use the formula force 1 over area 1 is equal to force 2 over area 2, where F is force and A is the area. But before we find the force of the second syringe can generate, we'll find first the area of the first and the second syringe. In finding the area of the first syringe, the given are, the diameter is equal to 0.157 meter and the radius is 0.079 meter. In finding the area, we'll use the formula area is equal to pi r raised to 2. So let us now substitute the value of the pi and the radius of the first syringe. It will now be area is equal to 3.14 times 0.079 meter raised to 2, and square the value of the radius. It will now be area is equal to 3.14 times 0.0062 meter square. Then multiply the value of the pi and the radius. It will now be area is equal to 0.019468 or 0.19 square meter. Next is we'll find the area of the second syringe 5 ml. In finding the area of the second syringe, the given are diameter is equal to 0.127 meter and the radius is 0.0635 meter. The same formula will be used in solving the area. Area is equal to pi r raised to 2. Substitute the value of the radius of the second syringe and the pi. Area is equal to 3.14 times 0.0635 meter raised to 2. So square the value of the radius. it will now be area is equals to 3.14 times 0.004 square meter. Multiply the value of the pi and the radius, it will now be area is equal to 0.01256 or 0.13 square meter. Since we already had the value of the area of the first and the second syringe, let us now find the force of the second syringe. In finding the force of the second syringe, we will use the formula F1 over A1 is equals to F2 over A2. Since we are looking for the F2, we need to derive this formula. And to derive the formula for F2, we will multiply both sides by area 2. Then we will cancel out the area 2 in the right side. The formula for F2 will now be F2 is equals to F1 over A1 times A2. So let's now substitute the value of the F1, A1, and the A2. It will now be F2 is equals to 47 Newton divided by 0.19 square meter times 0.13 square meter. So we will now cancel out the unit square meter. It will now be F2 is equal to 47 Newton times 0.13 divided by 0.19. 47 Newton times 0.13 is equals to 6.11 Newton. Then it will now be F2 is equals to 6.11 Newton divided by 0.19. 6.11 Newton divided by 0.19. The force that the second syringe can generate will be 32.1578 Newton or 32.16 Newton. Thus, we can say that by applying 47 Newton in the first syringe, the second syringe can generate a force of 32.16 Newton.